Okay, decryption is going to actually be same thing with encryption because I have a symmetric key. All I'm going to do is simply say encrypt, and that's pretty much all to decryption, because I'm assuming that my key is symmetric key. It can be used for both encrypting and decrypting. I'm just assuming that to decrypt the information, all I need to do is just say encrypt. Same procedure. Okay. What else? I'm missing something else, it seems. Let me just try to build this. Finish building. Okay. Let me run this. Oh, what is going on here? Exception. Array index out of bounds. Let me see where I do out of bounds here. Let me just key length. I was not expecting this to be out of bounds because my key is longer than my data. We will just create another, since we were trying to encrypt the name. We will just wrap around the key multiple times, right? So what we're going to do is that we'll create integer key index, which equals 0, and we will use a separate basically we will use separate variable to access the key right here. Okay, and every time we do this, we will increment the key index, and then if key index is how about this? If key index is less than key bytes dot length we will increment the key index. Okay, and otherwise we will set key index equals 0. Okay, just like that. So we use separate index to access everything inside key bytes, and so this way, if we run out of characters inside key bytes, we will just wrap around. We go back to key index 0. Okay, so let's give that a try. All right. I'll just run it. All right, so here we go. In main class, I'll just say print. We can say system dot out dot print print encrypted version is this, and then we'll say plain text version is this, right? So this way, if we run it, you can see that encrypted is something like that, and plain text goes back to Joe. So we can now use this make secure thing, right? And we can now encrypt with string key, right? And we can then provide, instead of hard-coded secret, we can provide a key, whichever we want. So this time, if we say make secure secret, we are encrypting with the secret key. then we can display what the encrypted thing is, and then we can again, after plain text, once again we can play with this secret hash, another encryption, and we can once again display the encrypted version with a different password, right? And then we say, okay, then go back to plain text, right? So we can play this game a few times to create an employee here with a certain name, Joe Doe, right? And then encrypt it once, show the encrypted unreadable stuff, then go back to plain text by decrypting it, then try encrypting it again with a different key, once again show what the encrypted version is, and then decrypt it again. What's wrong with that? Java out of bounds. So once again I got out of bounds on this line. What's wrong with that? If key index, as soon as so I increment one extra time my key byte index, right? Because I say as long as it's less than the length, go ahead and increment it, right? But it has to be less than length minus 1 to allow its increment. So that's why I think there was a problem, index out of bounds. Let's give this another try. So here we go. It's like it says, all right, the first time encrypted is something rather crazy, then we decrypt it goes back to plain text, then we encrypt it again, and it just actually, let's display what these characters are. Let's display what these characters are. Inside the employee, I will, for the lack of better idea, I'll just say Boolean encrypted, okay, which gives me indication whether my object is encrypted, and I will initialize, bless you, to be false. So we initialize it to be false. When we say encrypt, we will set encrypted to true. Okay, and then when we decrypt, we'll set encrypted to false. All right, false. And so this name, when I print, I can say if, right? If encrypted. If encrypted, then we'll just print those bytes, right? We'll just print the bytes. Otherwise, we'll just print the plain name so that we can see what the encrypted bytes are. Okay, so when stuff is encrypted, everything is stored in the name, and we're gonna say if encrypted, we're gonna do the same thing we did before. We're gonna extract the byte array out of byte what do I call it, name bytes, same way. Get name bytes out of name, right? Get name bytes out of name, and then basically have a loop, for loop for byte one byte in name bytes, right? We will say system dot print out. I'm sorry, system out dot print. Thinking too fast here. System out dot print, and I will print individual bytes. One byte. byte, and then we can also separate things by a space, right? Just use space to separate system out print. I'm missing a semicolon here, and I also need parentheses. I don't know why I used brackets. Okay, so this time I'm trying to distinguish between the encrypted and decrypted state, and so print bytes or print the plain text. So yeah, I need a new line at the end. Okay, let's just print new line at the end of this encryption stuff, print line, and just run it. So now the first time I encrypt with one key, which is a secret, and this is what it makes, right? This manufactures those numbers, and those are encrypted. Then I go back and decrypt stuff. So notice that the number of bytes is like 7, the same number as the number of characters. Then I encrypt with a different key, and that producing a different set of encrypted characters, and then when I decrypt it, it goes right back to Joe. So interesting. Let's discuss what the program does.